Hello everyone. In this video, we will look into two protocols which are used in video streaming. The first one is RTSP, real-time streaming protocol, and the another one is RTP, real-time transfer protocol. Basic workflow of RTSP. Initially, the client is in init state. Through the setup request, it is moved to the ready state. Now the client is able to stream the video. Through the play request, it is moved to the playing state, and through the pause request, it can again come back to the ready state. Through ready and playing state, it can come back to the init state through the tear down request, and the loop will start again. Basic workflow of RTP: get the request from the client, encapsulate the video frame, send the backend to the client. This is the header which is used to encapsulate the video frame. Although it is of 16 bytes, but in this context, CSRC identifier is of 0 bytes, so our header is of 12 bytes. Now, let's see the implementation of RTSP and RTP in Python. First of all, let's see the server side implementation. This is the server class. We are taking the server port through the command line on which we want to run our server. Then we will create the socket through the socket method of socket class by passing in appropriate parameters. Then we will bind this socket to the server port, and then we will listen on this server port. Through this accept method, we will accept the data from each and every client, and whatever the data that we get from the client, we will pass that data to this server worker class, and then we'll call the run method upon it. Now let's see the server worker class itself. So these are the four type of request which I mentioned earlier: setup, play, pause, tear down. These are different state: init, ready, playing. These are different type of responses: OK 200 for success, file not found 404, and 500 for internal server error. This client info is an attribute of server worker class. So through the constructor, whatever the data that we get from the client, we will assign that data to this attribute. Now, for each and every client, we will create individual thread, and we will pass this function to that thread, and we will start that particular thread. Now let's see this particular function. So this function is basically will receive RTSP request from the client. So first of all, it will extract the connection socket, and then will receive the data using this particular method. So now we have the data, but we need to decode it. So we will decode this data, and we will pass this decoded data to this particular function, which will process our data. Now let's see how the processing is done. So this is the example data that we will expect from the client. So in order to parse it, first of all, we will split it with the new line to process each line individually. Now then again we will split the first line from this space in order to get the individual parameter. The first parameter is our request type. It can be of setup, play, pause, tear down, and the another one is file name in our protocol, and these are some other information. So we will split the line 0 by a space, and then we will fetch the request type, which is our first parameter. Our second parameter will be line, file name, and the first parameter of the second line will be our sequence number. Now based on the request type, we will process it individually. So if my request type is setup, so whatever the file name that is requested by the client, we will create the video stream for that particular file. So this video stream class is basically accepting the file name, and it has two methods, next frame and frame number. Next frame will return the next frame for that particular file, and this frame number will return the frame number for the current file name. So if file is not found, then we will return the 404 not found error. So for session, we will randomly create an session ID, and then we will reply back, okay, your request is completely processed. So similarly, if my request type is play, then first of all, we will create the socket by passing in appropriate parameters, and we will reply back with a success response. Now for each request, we will create a thread, and we will pass this send RTP function to it, which we will look further, and then we will start that particular thread. Similarly, if my request type is pause, then I will set means pause my thread, and will return success response. Similarly, if my request is tear down, first of all I will pause that thread, return the 200 response, and then close that particular thread in order to terminate the connection. Now let's see this send RTP function. So it will send RTP packets over UDP. So first of all, we will check whether it is a pause or tear down request, then we will simply break. But if it is not, then using the video stream class that I have mentioned, we will create the next frame function, and it will return me the next frame of the requested video. And from the frame number, we will extract the frame number. And through the client info, we will extract the address and port on which our client is running. And through the send to function, we will pass our RTP packet to that address and port. Now, this make RTP function will get the data and frame number, and it will convert that video frame into an RTP packet. Now let's see how it is implemented. So these are the some flags which need to set in the header, which I described earlier. So through this RTP packet class, we will encode this data frame into RTP packet, and then this will return the packet. So this encode is taking version, padding, extension, CC, sequence number, marker, PT, SSRC, and payload. Now let's see how this encoding is carried out. Class which is used to encapsulate the video frame. It has an attribute header, and as I mentioned earlier, our header is of 12 bytes. So length of this header is of 12 bytes, and each of index of header is of 1 byte, so total 12 bytes. It has a encode method which will take different flags like version, padding, extension, CC, sequence number, marker, payload type, SSRC, and the payload itself. So we will fetch the current time step, and we will assign the header to the 12 byte of byte array. Now let's see how the encoding is carried out. So this is our RTP header. Now in the first byte, we will set this version, padding, extension, and CC flags. So in the first 2 bytes, we have set the version by left shifting the version by 6 bytes. Similarly, the third bit is set to padding by left shifting it by 5 bytes and using bitwise OR operator. Similarly, extension, left shift it by 4 and do a bitwise OR with the header. Similarly, CC is set. So setting of first byte is done. Now the first bit of second byte is set to the marker bit, and the rest bit of second byte is set to payload type, which is 26 in our case. Now our sequence number is of 2 bytes, but each of header index can store only 1 byte. So in order to sequence number, we have split the sequence number in a chunks of 1 byte. The first chunk of 1 byte is stored at second index and the rest is stored at the third index. Similarly, timestamp is of 4 bytes. So in order to store it, we have splitted the timestamp in a chunks of 1 byte, and each of chunk, the first 1 byte chunk is stored at fourth index. The another 8 bit or 1 byte is stored at the fifth index, and similarly the rest are stored. And the same approach is used in order to store the SSRC identifier. So this is how the encoding is carried out, and then we will assign the payload uh, to the payload attribute. So these are some helper function. Decode, it will basically take the byte stream and it will extract the header and payload. So first 0 to 12 bytes will be of header and the rest will be my payload. Similarly, in order to get the version, we will just do a right shift of first header and we will get the version. Similarly, we can get the sequence number using bit manipulation, timestamp by combining 1 byte of chunks to get the exact timestamp, payload type, then get payload function will return this payload, and get packet will combine the header and payload and it will return it. So this is how RTP packet class is encoding a video frame. So this is all about the server side implementation.
Let us now have a look at the client side of the application. In the main function, we are getting four command line arguments: server address, server port, RTP port, and file name. Then we are initializing a tkinter application with assigning it to the root. We are passing this root and the server addresses to the client constructor function, which will then be stored in the app. And finally, we are making the title RTP client of this tkinter application and running the main loop of this tkinter. Now let us have a look at the client application. In this client class, we are defining the initial state to be an init. In the constructor function, the master will represent the tkinter root, while the addresses and the ports are copied as it is. There is one protocol which is added to the master when the user presses the cross button. It will ask the user if he or she wants to exit the window, which is handled by this handler. Here it will ask for, are you sure you want to quit? If the reply is positive, then we will exit, else the movie will continue to play if it has already begun to play. Then we have this connect to server function which will connect to this server address and server port by creating a sock stream socket. Here is the socket, and here it will try to connect to this server address and port, and if it encounters any error, tkinter will show a warning message for the same. Next, we are also defining the RTP socket, which will be used to stream the video from server to the client. And here we are using SAW DGRAM for the streaming protocol. There is also one function called create widgets, which will be used to initialize these buttons and the image for which the video will be displayed. The buttons are setup buttons, start button, pause, and tear down. And there is one label which will be used as an uh, video display for our application. These are the functions which will be executed by the buttons when they are clicked on them. We can see this setup movie called here when the setup is having this command of setup movie. Similarly, exit client will be run when there is a teardown uh, event. Similarly, pause and play movie when the movie is played. Let us have a look at them one by one. Setup will initialize the state to init, check if the state is in init, and send the request for the setup. Similarly, exit client will send a request for teardown, and it will destroy the tkinter application. Pause menu will check if the video is already playing. If it is, then it will send a request to pause the streaming. And play movie will check if it is the state is in ready state, and if it is, it will create a thread for receiving the RTP video. And there is also one threading event associated with it, which is stored in the play event variable. We are initially clearing the flag so that it can be set and can be set to wait after as we want. We are also sending this play request to the server. So these are the functions which will be executed when we press on the buttons. Now let us have a look at this listen RTP function. This listen RTP function will be called by this play movie button when there is this thread created. It will run this function. So what it will do, it will run an infinite while loop while it will constantly fetch data from this RTP socket, and if it has some data, it will initialize a RTP packet. It will this decode this data using this packet and get the sequence number. We will print this sequence number, and if we find that the current frame number is greater than what the frame we have last obtained, we will update our current frame number, and we will also update the frame. We will have a look at this write function when we it is just below. If this try block gets any errors, it will check that if the play event is set, then it will simply break out of this loop because we are in pause or tear down state. Similarly, if there is an tear down acknowledgement received, the RTP socket will shut and also close. Now let us have a look at this write frame. This will take the data and it will open up a cache file which will be named after the session ID. And after it is opened, the data will be written in it and it will then be closed. This data will be then used to update the movie as we have seen in this function. In this function, there is this photo which is opened using the file name, and here we will pass this file name which is written by this cache name, as we can see it here, that the payload is obtained and we have written this to this file and the name written from this write file frame function will be then used to give it input as update movie. So we will now get the latest frame for which the video will be displayed, which is this label. This connect to server we have already seen. It will try to connect to the upstream TCP server, and if there is no error in the connection, we will get the connection, else there will be an error message shown that connection has failed. Now this is the function which we were told to complete in this assignment. So this function will receive the request code as a parameter to this function, and we will check that first that if this request code is set up and we our current state is in it. If that is the case, we are ready to move to the next step, which is we are uh, ready for receiving the video stream. So we will create a thread which will receive the RTP replies constantly. The replies will be the sequence numbers and the session IDs respectively, which will be handled by this thread. We also initialize the RTSP sequence to be 1, and we will frame this setup according to what we have been given in the assignment PDF. we will have this keyword setup, then followed by the file name. Then we will have a new line representing the second line will have the RTP sequence, and last line will have the version and the protocol and the port number as well. Now we will send this request by encoding it using the Python's encode function using this UTF-8 encoding, and we will also store the request sent to self.setup so that we can keep track of which request was sent. Similarly, if the request was play and we are in the ready state, then we are good to go and play the video. We will increment the RSTP sequence by 1. We will formulate the request as given in the PDF by having this keyword play, and in the next line we will have the sequence number. Then we will send this request by encoding similarly what we have done here, and for debugging purpose we have also printed this line. Same goes for the pause. If there is a pause, we will increment the sequence number, formulate the request, send it, and uh, keep track of the request. And for tear down as well, increment the counter, appropriate request, and sending the request. Finally, we are also printing the data and which is as a request which was sent to the server. In this RTS reply, we will be constantly looking for the replies which the server is giving. And if there is some reply which will be handled here, then uh, the parse RTSP reply function will be ran, which will run on this reply.decode. Decode will decode the encoded bits which was sent by the server. If the request sent was tear down by some chance, then we would have to shut down this socket and close it as well. Now, what this RTSP reply function does is that it splits the data sent by the server into different lines, and we know that the sequence number will be present at the second line and it will be the second word. So we can, using this split function and typecasting, we can obtain the sequence number. After checking that the we have the sequence number same as the sent by the RTSP sequence, we can assure that this is the correct reply. Further, we check this by having verification by sessions. So we obtain the sessions which will be present in the third line and which will be also at the second, which will also be the second word. We check that if the session ID is 0, which means that it is the first session of its kind. So we will initialize the session ID to this session. Else, if that is not the case, then we will check that the session ID and the session are indeed the same, so that we are getting the reply for what we were thinking that it is going to give the reply, the server. We will check further after this verification that the status code was okay. If that was the case, then we have acknowledged this request, and we can now uh, change our setup to ready state, and we can now open this port RTP port for binding. This will be done by this function. We will have a look at it in a bit. Now, if that was not the case, if that was not the setup, we have already set up the connection, and it was rather the response was for play. Then we can change the state to playing. Similarly, if that was the pause, we can now instead of playing, we will roll back to one state, which will be the ready state, and we will pause the play event, which will in turn pause the execution of the thread which will be receiving the TCP video streams. If the request sent was for the teardown, then we will simply set the teardown acknowledgement to 1, which would then be taken care by the one of the functions above as we have looked. Now, what this open RTP port will do when it receives the setup kind of reply. So it will set a timeout of zero point 0.5 seconds or 50 milliseconds, and then it will try to bind to this server and the RTP port, which will be then used to connect to the RTP port, uh, which is another thread listening listening and sending data to the server, which is the video stream itself. So this was the explanation of the client and the client launcher uh, Python module. Now we will have a look at the application itself. First, we will begin by running the server at the port localhost 8080. Then we will create a client application on localhost itself with port 8080. 5000 will be used as the RSTP port. The file name is movie.m. This opens up the Python tkinter GUI application. We can hit setup, and we will get the server will get an appropriate header message. As we can see here, we can hit start to begin the stream, hit pause to pause the stream, and we can also observe the uh, data being received, the headers actually, the command and the sequence numbers, pause and 3. We can again hit start to begin the stream, pause, and then if we wish to close this application, we can hit teardown, which will then send the teardown message. Similarly, in the client terminal, we can see that there was the same header was sent to server, which was also printed here, and we have some prints to see that the request was sent. Then we can observe the sequence numbers which each frame were sending until a pause message was encountered, and which was then again resumed by this play. And we can observe that the sequence number continued where it were left in the previous session. So this was all about the assignment, TCP and RSTP video streaming. Thank you.